Hi, I'm Kirsten Chick, author of Nutrition Brought to Life, and this podcast is a companion to the book. You can listen as you read Nutrition Brought to Life, or before as a kind of preview, or after you've finished the book as a refresher. Either way, I hope this helps you make some small changes that make a big difference in your life. Hello, I'm back, and thank you for sticking with this. Or perhaps you're new, in which case, welcome to the Nutrition Brought to Life podcast based on my book of the same name. This episode and chapter is an introduction to your immune system, what it is, and some of the nutrients it needs. Then next time, we're going to look at more ways to strengthen and support it. Immunity has been a hot topic of late. There's never been so much talk in the mainstream media of antibodies, T cells, and immune responses. But do you really understand how your immune system works? Actually, does anyone? It really is a complex and amazing aspect of your inner universe, and scientists will readily admit our knowledge of it is still quite superficial. So I'm going to attempt to give you a concise overview, but please remember this is all just the tip of a very impressive iceberg. The purpose of your immune system is to protect you, largely from infection. When you're swimming in a bacteria-infected pond, for example, perhaps even drinking some of it in, it's good to know your body has ways to try to protect you from getting ill or even dying. Equally, if you cut yourself with something that's not sterile or accidentally stand in the way of a sneeze. So first of all, you have a number of barriers to infection. Your skin, for example, is there to stop a lot of things from getting in. You also have a long tunnel from your mouth to your anus that's lined with a mucous membrane that's similar to your skin. Other nooks and crannies are also lined with such a membrane. They're not completely impermeable, but they do represent physical barriers to large molecules entering your bloodstream and tissue. The mucus that lines those more internal membranes is another such barrier. So is the acid in your stomach, which will kill a lot of microbes you might inadvertently swallow. Then you have your microbiome, your own colonies of bacteria and other microbes, which I talked about in chapters 11 and 12. In addition, there are things like antimicrobial proteins that roam your protective surfaces to help deal with external infections. If there's a lot of bacteria or virus particles all invading one place, those barriers can sometimes get overwhelmed, like a crowd surging past security. Or sometimes those barriers can be compromised, so perhaps the skin is weak or broken, the mucous membrane's inflamed or not producing the right amount of mucus, or maybe the microbiome is out of balance and so not able to do its job properly. That's why it's so important to look after all of these, and why there are previous chapters on how to do so. These barriers are not our only protection, however. There's also internal security, largely in the form of white blood cells. If you cut your finger with a dirty knife, for example, the tissue in that area will quickly become inflamed. This inflammation is part of your healing response. There's usually heat and swelling, and the local blood capillaries dilate. White blood cells called neutrophils squeeze out from the blood into the tissue to destroy bacteria and other pathogens. These are like bees that sting once and then die. Then they turn into the pus you sometimes see in wounds. Other white blood cells, called monocytes, also leak out of the dilated blood vessels, immediately transforming into larger cells called macrophages that help mop up the neutrophil pus. If these white blood cells manage to keep on top of things, then the inflammation will calm down, the area will heal, and everything goes back to normal. Inflammation is generally a helpful process. But long-term, low-grade inflammation that never gets a chance to properly resolve can trigger and drive many different illnesses and conditions, such as type 2 diabetes, heart disease, cancer, asthma, eczema, inflammatory bowel disease, arthritis, and depression. If this layer of your immune system is breached, however, all is not lost. There are further lines of defense as you go deeper into your body. Some of these are more physical barriers, such as your blood-brain barrier that helps to stop certain things getting into your brain. There are also inflammatory processes providing immune activity in your blood vessels, your organs, and throughout your body. There are also things like natural killer cells that can, for example, kill any of your own cells that have become infected with a virus or that has become cancerous, for example. There's a part of your immune system that has been primed to look out for specific viruses and other substances that it has come across before. This is called your acquired or specific immunity. And this is where the antibodies and T cells you've been hearing so much more about recently, this is where they come in. There are two types of white blood cell involved here, T cells and B cells. Your B cells are trained to produce antibodies in response to specific substances, such as a flu virus or something you're allergic to. They only respond to the specific thing they have learnt to respond to. So you have many different B cells, each trained to produce different antibodies. Those antibodies can then destroy their target or stick to it and deactivate it, or mark it out to be destroyed by a white blood cell, such as the neutrophils and macrophages we talked about earlier. T cells are also each trained to just deal with one type of virus, bacteria, or toxin. Cytotoxic T cells can destroy any of your cells that are infected with the substance it's been trained to recognize. So very simply put, antibodies can kill the invaders or put a hit out on them and are produced by white blood cells called B cells, while T cells can kill any of your cells that have been infected, but only if they've been specifically trained to deal with that specific substance. But it's not that simple. It's vastly more complicated. So nutritionally, we generally think about providing your body with the nutrients it needs and then letting your immune system sort out what it needs to do with them. The main nutrients you need for making white blood cells of any sort, or leukocytes as they're also called, are vitamins A, C, and D, and the minerals selenium and zinc. The best sources of vitamin A are liver and eggs, but you can also convert the beta-carotene in orange and green leafy vegetables to vitamin A. Vitamin C is rich in raw fruit, raw leafy green vegetables, and raw onions. Vitamin D you can get from oily fish and the sun, but only if it's high enough in the sky to make your shadow shorter than you are. A couple of Brazil nuts or some oily fish will give you plenty of selenium, while zinc can be found in nuts, seeds, chicken, lamb, and peas. So, a rocket and watercress salad with mackerel and toasted pumpkin seeds would be perfect and would also provide you with the protein you need to make antibodies. Let me know if you come up with any other recipes your leukocytes will love. And then next time, we'll look at more ways you can strengthen and regulate your immune system. Thanks for listening to the Nutrition Brought to Life podcast. There's also a Facebook group you can join called Nutrition Brought to Life Podcast Community, where you can share useful insights and recipes, ask questions, and get more support on your nutrition journey. If you haven't read it yet, there's so much more in the book, Nutrition Brought to Life, as well as all the scientific references and some glorious pictures. And you can find out more about me at kirstenchick.com.